Pick a perfect circle, like this one I drew. Now place a perfect triangle inside of it, like this one I also drew. If you were to draw a random line between 2 points on the edge of the circle, what is the probability that the line will be longer than the length of the triangle's lines? This is the setup for what turns into Bertrand's paradox of probability. The answer is that the probability changes depending on how you pick what lines to draw. If you pick 2 different points on the circle itself and draw lines that way, you have about a 1 in 3 chance, or 33% for normal people, of creating a line longer than the edges of the triangle. That's one method. If you draw lines in the same direction across the circle at random points of the circle, that's a 1 in 2 chance, or 50%. That's another method. If you place a dot inside the circle and use that as the middle point of the line, you have a 1 in 4 chance, or 25%. Yet another method. What this shows is that the way you define random changes the outcome of that randomness. The paradox is that you can't have objectively random outcomes when there are infinite possibilities. Something like that. I had to sift through math nonsense to parse the idea behind it. I'm not going to talk about the math of it, because that's for nerds. Bertrand's paradox is just the mathematical version of basic methodology. Here's an example. If you survey random people on a beach about whether or not they like the beach, is this a biased survey? The answer is yes. The survey would be laughable and invalid. It's framed as random selection, but that random selection takes place within a certain group of people. It's not actually a good representation of how people largely think, because you've already filtered the potential answers by selecting people who are already on the beach. This is selection bias in science, and this paradox just reminds us in very nerdy terms that we can't create or account for anything objectively random. To account for objectively random things, we would have to account for things outside of our perception and awareness, which isn't possible. If we can frame it and give it enough context to measure it, then it's not random. Now you might be wondering, if nothing we do can be random, then is everything we do already decided? I've already talked about this multiple times, but the quick answer is no. Not everything is predetermined. I can argue for that just by using the funny diagrams made by this paradox. If everything were predetermined, how come changing the method of picking where to draw lines changes the probability? Maybe consider that this paradox is actually proof that the method which we interact with the world changes the potential outcomes that we experience. If somebody drives a car and decides to try texting at the same time, their interaction with the world has increased the odds that they will be in an accident. It does not guarantee an accident, but it does make it significantly more likely. By not paying attention to the road, they've shifted the odds in favor of crashing. You could call it the inattentive driving method, while I myself use the cautious driver method. My method is less likely to get into an accident, and even if I did, it likely wouldn't be my fault. My decision improves my odds, and understanding this is just a fancy version of knowing the risks. Math implies that random doesn't exist, and I think, yeah, that's probably true. Everything happens for a reason in the real world, even if that reason is incomprehensible or unknown.